Good morning, students, and welcome back to my digital classroom once again. I hope that you all are quite well and doing your work regularly. Today, I will revise the chapter Squares and Square Root. I have given enough time to explain this chapter in my previous 2-3 classes, and I have given some inputs more than your textbook. Okay, so today basically I'll be explaining the most important part of this chapter, which we need to remember throughout your life, and thereafter I'll be explaining some of the textbook questions orally. Okay, let's see. Again, begins with square. Square is what? When a number multiplied by itself. When any number is multiplied by itself, the product often is called the square of that number. Any number, 3 into 3 is 9. So, 9 is the square of 3. 12 into 12 is 44, that is 144. That is 144 is the square of this square. Now, meaning of perfect square. A square of natural numbers are square number of perfect square. It means what? Suppose m a number, natural number, it can be expressed at n square. Then n is also a natural number. Then m is called the perfect square number. So 25. 25 can be written 5 into 5. That is 5 square. So 25 can be written 5 square. They are perfect square. That's why I'm able to represent them in a perfect square. That's why it's a perfect square number. Sometimes what happens, you see, important area, 18. 18, if I factorize 18, then I will be getting 3 into 3, but there is no pair of 2. So a perfect square number will always have equal pair of prime factors, equal pairs of prime factors. If it is not, then it is not a perfect square number. Mind it. Okay. Next time coming to what? This is very important chart. I told you earlier also. 1 to 30, minimum 1 to 30, you have to remember the square of 1 to 30. Okay, it will help you a lot when you perform a square root activity. It will help you a lot. Please remember, you have to memorize the square table of square from 1 to 30. Then only you can do your work very fast. Now, properties of the perfect square number. From this table, we have noticed something. If we go through the table, you will notice any number ending with 2, 3, 7, 8. 2, 3, 7, 8. If it is given, directly say, no, this is not a perfect square number. Any number ending with 2, 3, 7, 8 will not be a perfect square number. But other than 2, 3, 7, 8, like 1, 4, 5, 6, 9, and even number of zeros, it may be a perfect square number. Not exactly. Why? Say 4 is a perfect square number, but number ending with 4. But 14, 24, 34, so many 4s are there. They are not perfect square. That's why the chance it may be a perfect square number. Your answer will be an even number of 0. 100 having even number of 0. 100 is a perfect square number. 10 into 10 equals to 100. But 200 is also having even number of 0. Okay, 300 is also having even number of 0, but they are not perfect square number. That's why your answer, number ending with 1, 4, 5, 6, 9 and even number of zeros may be perfect square number. Okay, and another property is that if we find out the square of even natural number, it will be even. If we find out the square of odd natural number, it will be odd. Okay, this one rule. Another is number ending with 1 and 9. The unit place will be definitely 1. Okay, if any number ending with 1 or 9, the unit place definitely will be 1. So square of the unit place is 1. Number ending with 4 and 6, definitely the square will be 6. Unit digit of the square will be 6. 2 or 8, definitely it will be 4. 3 and 7, it will be end with 9. Square, unit digit of the square. 5 definitely 5. 1 0, it will be even 0. Okay, so this way, when the 2 zeros is there, then we have 4 0. 4 zeros is there, 8 zeros. Just you have to double it after squaring. Now, how can you express any number as a sum of the two consecutive number? Very important. Okay, for your class test also. Okay, say one number. The formula is n square minus 1 by 2, n square plus 1. Suppose 7 square 49. Question is that 49 you have to represent by what? As a sum of the two consecutive number. Okay, the formula, what is the square of 49? 7 square 49. 7 square minus 1 is what? 2, there is 24, and plus 1 25. If I add 24 plus 25, it will be 49. So 49 number we have to represent by what? By sum of the two consecutive number. Two consecutive. This, other than this combination, you cannot get. You cannot show the sum of the two consecutive number is 49, other than 24 and 25. So what to do? First you have to find out the square. 49 is the square of 7. The 7 square minus 1 by 2, 7 square plus 1 by 2. This is the expression. Okay. So like 81. So 81 is the square of 9. Okay. Then how will you represent? 9 square minus 1 is the 40, and 9 square plus 1 is the by 2 equals to 41. The 40 plus 41 is equal to 81. 13 square is 169. Okay, how can I write down? 13 square minus 1 by 2 is equal to 84. 13 square plus 1 by 2 is 85. 84 plus 85 equals to 0. So question will be coming from here. The example, like we see 169, 81, 49, you show the sum of the two consecutive numbers. Okay, so with the help of this form expression. Acha. Now, if you like to find out the product of two consecutive odd number or product of two consecutive even number, so simply you can perform this. No need to follow the proper multiplication. Okay, 11 into 30. What is the number in between 11 and 30? 12. So answer is 12 square minus 1. 12 square minus 144, minus 1 is 43. Clear? The explanation is there. 12 square can be written 12 12 square minus 1 what? 11 can be written 12 minus 1, that is 13, and 13 can be written 12 plus 1, that is also 13, by algebraic a plus b into a minus b. Algebraic expression, that is identity, a plus b into a minus b is equal to a square minus b square, that is 12 minus 1, 12 plus 1 is equal to 12 square minus 1. This you no need to show, that's I'm proving it. Okay, you have to remember what is the number in between, that square minus 1. So 13, 11 into 13, in between 12 is there, 12 square minus 1. Okay, obviously it will be whatever the number is the product. So I have given the odd number example. So if it is even number, you see 24 into 26. What is the number in between? 25. So what will be the number? Product of this 24 and 26, 25, 25 square minus 1. 25 square is the 625 minus 1 is 624. So you will say, sir, how will make out 25 square? That's why I'm telling you have to remember the table of square from 1 to 30. Minimum 1 to 30 is must. Okay, you must practice. 48 and 59 square minus 1. 59 square is this, minus 1 is this, that is the 2400. Clear? Now, earlier we have performed an activity of Pythagoras theory. That was that we have proved with the help of some paper cutting. Okay. Now, in algebraic method also we can prove that Pythagoras theory. Pythagoras theory is what? A square plus b square is equal to c square, or any alphabet. X square plus y square is equal to z square. Through an algebraic method, how can I prove? We just see. Okay. So algebraic x square plus y square is equal to z square. How? How it is x square plus y square z square? That we have to prove. This is the new one I am just telling today. You remember it. Earlier I have not shown you. Okay, time was short. That's why. X square plus y square is equal to z square. How? Suppose I have drawn a line segment. Okay, and I have just divided into unequally two parts. First part, let first part be x, second part be y. So the whole line segment is the sum of x plus y. Okay. Now taking this measurement of one side of a square, if I complete the figure, it will be a complete square. What is the area of the square? Side square, that is x plus y whole square. All are xy, xy, xy. That means all are having the same measure. What is the area of this square? X plus y whole square. Now if I join the all points like this, so I am getting what? I'm getting a small square inside the big square. So take the measurement, this sides be z. Okay. So what is the area of this small square? Z square. Definitely z square. Now we have to prove the first. Now how can I prove this whole square equals to the small square plus sum of the four right triangle at four corner? Clear? Have understood? Big square, that is x plus y whole square, is equal to small square made inside plus four triangle, right triangle at four corners. Okay. So now what is the formula identity I am going to apply? A plus b whole square. A plus b whole square is equal to a square plus twice ab plus b square. What is a here? X. What is b here? Y. That means in this case, what will apply? X plus y whole square, that is big square, area of the big square, x plus y whole square equal to small square. Small square, each side is z, that means z square. Okay, that means z square. Clear? So small side is the z square. Now fourth triangle, that means 4 into half base into altitude. So this half and this 2 cut, I'm getting what? 2. Okay. So now if I expand this one, so a square, a plus b whole square, that is x square plus y square plus 2xy. So now you cut 2xy to both side cut. What I am getting at the end? X square plus y square equals to z square. That is proved. Have you understood or not? Shall I explain again? Okay, let's see. This is the new concept again I'm showing you. Clear? So by algebraic method, how can I prove Pythagorean theorem by algebraic method? Okay. So now for this, what is the Pythagorean theorem? A square plus b square is c square, or x square plus y square is equal to z square. Any three alphabet we can take. For this, what to do? We have to draw a line segment, and we will divide it to unequal part. So let the first part be x, second part be y. Okay, so that means this line segment is the sum of two units. Okay, x plus y whole square. Taking this whole side as a side of a square, if I complete, I will get what? One whole square. Where area of the whole square will be what? Any side whole square, x plus y whole square. Here also x plus y, x plus y, x plus y. So area of the whole square will be side square, that is x plus y whole square. Now, if I join the points one by one, what I'm getting? I'm getting another square. Okay, I'm getting another square. Each side of the square is z. Now you say, what is the area of the whole square? Whole square area is equal to x plus y whole square. That will be equal to small square, that is z square, plus 4 right triangle at 4 corners. Clear? Small square z square plus 4 right triangle on the 4 square. So now which method I am going to apply? Algebraic identity a plus b whole square. After few days you will be getting it. A plus b whole square, if it is there, I can write down a square plus twice ab plus b square. What is a here? X. What is b here? Y. So x plus y whole square is equal to, that means whole square area should be equal to small square z square. Small square is z, each side is z square, and 4 triangle. Here this 4 triangle is there. 4 triangle. One triangle is half base into altitude. The 4th triangle is equal to 4 into half base into altitude. This half and this 4. If I cut, I am getting 2xy. And if I expand this, it will be x plus y whole square, means x square plus y square plus 2xy. And another one is z square plus 2xy. This 2xy and this 2xy cut. What I am getting? X square plus y square is equal to z square. That is the theorem. Are you clear? Now I'm coming to next. Pythagoras triplets. So I already have explained also, but this is since the most important part, I'm explaining again. Pythagoras triplet. In Pythagoras in lower classes, what you have understood, when two members are given, then only you can find out the third member. But here I will give you one member, and you have to find out the other two members. Okay, how it can be done? So say Pythagoras triplets are 3, 4, 5. 3 square plus 4 square is equal to what? 3 square is equal to 9 and 4 square is equal to 16. 9 plus 16 is 25, which is equal to 5. That means 3, 4, 5. These numbers are the Pythagoras triplet. Similarly, 6, 8, 10. 6 square is 36, 8 square is 64. On adding, I am getting 100, which is equal to 10 square 100. That means 6, 8, 10 are the Pythagoras triplets. Okay. Similarly, 5, 12, 13 also Pythagoras triplet. Now, how we will find out when is one member is given? The expression is 2m m square minus 1 m square plus 1, where m will be greater than 1. So whatever the value is given, one member is given, you have to consider is that 2m. Okay, say one example. So find 12 square. 12, one member is 12. How to find out the other two member? So 2m is equal to 12. So therefore m is equal to 12 by 2, that is 6. Now other member will be m square minus 1, that is 6 square minus 1, and m square plus 1, that is 6 square plus 1. The 6 square minus 1 is equal to 35, and 6 square plus 1 is the 37. So Pythagoras triplets are 35, 37, and one member given 12. Understood? So I told you earlier also, Vedic method is also very interesting method. By this method, you can easily find out the other two members of the Pythagoras triplet. You see, very shortcut method also. Suppose at right triangle is drawn, its one side altitude. Whatever the side is given, either base or altitude, can't be hypotenuse. Okay, remember. So this one side is given altitude 7. How can I find it out the other members? Okay, what to do? First, we have to make a square of the given value. 7 square 49. Make it half. 49 by 2, 24.5. Make it whole. Now 24.5. If I like to whole, either you have to delete 0.5 or add 0.5. If I delete 0.5, it will be 24, and if I add, it will be 25. So Pythagoras triplets are 24, 25, and 7. Okay, the 25 is the hypotenuse, and 24 and 27, these two are the legs of the Pythagoras triangle. Okay, right triangle. Another example, suppose base is given 9. How will you find out the altitude and hypotenuse by Vedic method? Okay, so whatever the value is given, same 9 square, there is 81, make it half, 40.5, make it whole. So either it will be 40 or 41. So the other members will be 40 and 41. Greater one always will be the hypotenuse. Okay, 40, 9 and 41. This combination is also Pythagoras triplet. 7, 24, 25. This combination is also Pythagoras triplet. Clear? Now, what happens? Whatever the example I have taken, this that was what? That was odd number. Suppose this time I am taking even number. So in this case, even number is there. I cannot apply directly the previous method. Okay. So now what to do then? We have to break down 20 into such a factor where at least one will be odd number. So 20 can be represented 2 into 10, 2 also even, 10 also even. I cannot take. What is the other combination of 20 to represent? 4 into 5. 4 to 5 is a 20. So 4 is even, 5 is odd. Okay, that can be accepted. So now 20 will have to convert into 5. How? You divide by 4. So it will be 5. Now 5 is odd number. Follow the previous method. Find its square, 25. Make it half, 12.5. Make it whole, either 12 or 3. But this 12 and 13 are not the answer, because you have got it after dividing by 4. Now real numbers will be what? So you have to multiply it by 4 again. After getting this way, you have to multiply it by 4. So 12 into 4, 48. 13 into 4, 52. 52, 48, and 20. These are the combinations of Pythagoras triplet. Understood my point? So please follow this method. It is very interesting and time consuming also. It is not time consuming. It can save your valuable time. Just simple. Make it square, make it half, and whole. That's finished. Now long division method. Many of the students WhatsApp, you talk to me, sir, I didn't understand about the long division method, so please explain. I told them please wait for revision. So now I'm showing you one pre-solved question. The question is what? Thereafter I'll solve some directly live solve. I'll show you. Okay. 390625, we have to place a bar over the pair of numbers starting from unit place. Remember, starting from unit place. If you say, sir, if I start from this side, same result will come. Yes, but if it is a odd number of digit is in odd, you cannot follow this way. That's why main procedure is that you have to place a bar over the pair of numbers starting from unit place. Okay, so this. So you have the one pair 39. You have to consider such a number which when multiplied by itself it comes to 39 or very close to 39 but not more than 39. So such number is 6. 6 is 36. 7 7 is 49. 49 you cannot take. 6 6 is 36. You write down here 6. You write down here 6. Now you either add 6 plus 6 12. Leaving this one 0. You consider this one is a 0. Okay. Remember. And now bring down the second pair of number 306. Number is 306. And you have 120. Remember 100 0, if you are considering 0, 120. How much you have to write down? You can write down so that it comes to 300 something, not more than 306. It should be within the 306. Okay. So if I write down 3, so 366, but I have, if I write down here 3 multiplied by 3, I will be getting 366. It is more than 306. That's why I have to write down 2. And 2 is multiplied by 2, quotient also is 2, and result is 244. Subtract, I'll be getting 62. And bring down that 25 here. So since I have told you these are the perfect square number, so number ending with 5, definitely it will be 5. So if we add here, so it will be 1 for 24, 1 2 2, and then 2 adding 2 24, or you can 62 make it double 24. Both way you can do. You have to imagine there is a 0. Okay, 0 is here. Clear? So now if I write down 5 times, you have to write down 5 here, you have to write down 5 here. 3 part 5 5 5, and after multiplying it should come like this. It is coming 0. So that's why square root of this number is 625. Now another pre-solved example. Say it is a decimal part. Now what we'll do in this case, if I start from this side, it will not fulfill our purpose. It will be wrong. So from decimal part, you have to put a bar from this side, unit 10, and here, and other decimal part from this side. Okay. After 10th place, you have to start placing bar from the 10th place. 10th, 100, 1000, 10,000. Okay. This way. Now what is the number under first bar? Only 2. Which number when multiplied you get near about 2? So 1. 1 1 ja 1. So quotient is 1. Divisor also 1. After adding 1 and 1, I am getting 2. After subtracting here from this first bar, I am getting 1. Bring down the second pair 125. You remember here there is what? 0. So how many times 20 can go up to this much? 132. So 5 times 100, 6 times is 126. But see, if I write down 6, then it will be 26. 26 6 are more than 132. That's why I am writing 5. 25 5 is 125. Writing 5 here. After subtracting, I am getting 7. Now shift the decimal part. Bring down the second group of number 56, and 15 double 30. Okay. Now imagine there is a 0, 300. You have the 700 something. You have 300. How many times it can go? 2 times definitely. 3 times, if I write 3 times, then it will be 900 something. You have only 756, so it must be 2 times. Write down 2 here, 2 and 2. Okay, 3 combination, 2, 2 and 2 multiply together, I am getting 604. After subtracting, I am getting 152. Okay, and then finally I am bringing down last pair of number 25. Now what is the sum here? 304. You have to imagine there is a 0. Okay, and number ending with 5, definitely 5 will be there, because already this number is a perfect square number I have given you. Clear? So now 5 times, if I write down 5 times, 5 times and 5 times, and total after subtracting I am getting 0. Therefore square root of this number is equal to 15.25. Clear? Now I will solve some question decimal part, having decimal part. Okay, just listen. Say one question. Uh, One question. Question number 1. Okay, 26, 36, 26, 36. It will take time. Please bear with me. 36.30, 90 to 25. This is a number. You have to find out the square root. Okay, you have to find out square root of this number. What to do? We write again this number. Okay, 26, 36. Those who have not understood, follow my step. 30. Okay, 90, 25. I am writing with the help of mouse, so please accept it. Okay, now we have to place a bar over pair of number from this side, 36, 26, and from decimal part this side, 30, 90, 25. ठीक है? After that, divide it this way. Now I'm just rubbing it. It is not straight line. Now this way we'll just set a number. Okay, now what is the first bar? First bar is 26. Okay, so which number, which one multiplied comes to 26? 5. So it will be 5. Okay, so now 5 you write down here. So 5 5s are 25. 25. Okay, after subtracting we are getting 1. Clear? Bring down the next pair, that is 36. Okay, make it double, 10. How much you can? Another 0 is here, you have to remember. So that means 100 I have. So how many times it can go out of 136? One time only. 1, 1. You have to write down 1. Three places simultaneously. If we multiply, it will be 101 only. Okay, 101 only. If I subtract, I am getting what? 35. Okay, after subtracting, make it double, 102. Now you shift the decimal part here, bring down the next pair of number, so 30. Now you have 3530, and here you have 1020. You have to imagine 0, 1020. How many times it can go? Definitely 3 times, not more than 3 times. Okay, so write down 3 here, 3 here, and 3 also here. Now multiply, you will be getting 3 3s are 9, 3 to the 6, 3 to the 9, 3 to the 6, 0 and 3. 3 3 the 3. Subtract, we are getting what? 1, 6, 4. Okay. Now you bring down the next pair. Just erase this part. Okay. Okay. Now you bring down the next pair of number. Next pair of number is this one. What is this? 90. Okay. Make it double or add it. 1226 and 10. That means 10,000 you have. Or here you have the 46,000. How many times it can go? Definitely 4 times, not more than 4 times than 4,000. So you have to write down here. Four times. Here 4 times. Here you write down 4 times. Here you also you write down 4 times. Multiply. So after multiplication I am getting how much? 6, 5, then 0, 1, 6501, 4 minus how much you will be getting? This is 4. Sorry, this is 4. Imagine it is 4. 4, then 3, then this one is 1, and this one is 5. Now bring down the last part, 25, and as you know 25 means 5 is there, so definitely it will be the 5. So it will be 5 times, write down here 5, and here it will be what? 26, 64, 68, 1, 0, 2, 6, 8, and this number must be 5. Multiply it. So 5 5 is 25, 5 8 is 5 is 40 plus 2, 42, 5 6 is 35 plus 4, 34, 5 2 is 10 plus 3, 13, 13 is 3, and 5 2 5 1 is 5. So after subtracting I am getting 0. So 5. Therefore, so square root of 26, 36.309025 equals to what? Equals to 51.345. Got the idea? So I'm writing by mouse, so it is very difficult to write. Okay, that's why I had one example also. You have understood, I think. Okay, if you have not understood, please follow my video clip again and again. Then obviously you'll be able to understand what I'm saying. Okay. Now next part is what? Square root number by Vedic method. Okay. So those who are facing problem to find out the square root by long division method, when method is mentioned, definitely there is no way you have to follow that particular method. When method is not mentioned, number is big, So another when the number is very small, you can follow the prime factorization method. These are the two mainly. But Vedic method will apply when the decimal part is not there. Any whole number when decimal part is not there, you can follow Vedic method. Okay, the first example I am taking for you. Suppose 5929, I have to find out the square root of this number. Clear? So what to do? First we have to underline these two part. Okay, first part underline. So 29. So number ending with 9. What is the combination? What will be the unit digit of the square root? Either 3 or 7. This chart you have to remember. Otherwise you cannot solve. You have to remember. Okay. So very easy method. You no need to calculate too much. Okay. Then unit digit may be 3 or 7. It is not clear which one will be. But it will tell you after the second digit. What will be the 10 digit? 59. You have the 59. 59 comes after squaring of which number? 7 7 ja 49, 8 8 ja 64. It is more than 59. You cannot take 64. So I am getting 59 after 7 square. So my 10 digit will be 7. Okay, the 10 digit is 7. Now if 10 digit is 7, then what will be the unit digit? Now that will decide this 59 is very close to bigger number or smaller number. So two square numbers 49 and 64. So 59 is close to 49 or 59 close to 64. It is very close to 64. That means greater number. So you have to take this greater number. Earlier it was 7. So this square will be the 77. Have you understood? So first digit maybe 3, maybe 7 will determine after getting the 10 digit. Okay, 10 digit. So it comes after 7 square. That's why 7. And if it is 7, then unit digit will be what? 59 is very close to 8 square. That is greater number. So greater number is 7. So another 7 is there. Okay. Now next example. Underline these two pair. 4. Number ending with 4. What will be the unit digit? Either 2 or 8. Okay. So option is 2 or 8. It is not clear whether it will be 2 or 8. What is the remaining number after 0 4? There is 96. 96 comes after squaring which number? Definitely 9. Not more than 9. So 9 9 ja 81. So 9 will be the 10 place. Now 96 very close to 81 or 10 10 ja 100. It is very close to 100. That is 10. So greater number you have to take. So it will be 98. So 10 digit 91 and 90. That is 81. That is 9. And 96 is close to 100, not the 81. That's why greater number. We have the two numbers. Smaller is 2 and greater is 8. Since it is close to greater number, you have to do the greater number here, 98. Okay. Now another, underline first 96. Number ending with 6. What is the number? Either 4 or 6. So it will be either 4 or 6. Leaving this part, what is the next number? 40. 40. So 40 comes after squaring which number? 6 is the 36, 7 7 is the 49. So it comes after 6 square. Okay, that is your 10 digit will be 6. Now this 40 is very close to 36 or 49. So it is far away from the 49, but it is very close to 36. That's why this time we have to take the smaller number. So this number was what? 36. This will be 36, that is 6, and unit digit will be very close to the 6 square, that is 4. That means 64. Square of 4096 is 64. Any doubt? This is very interesting method. Please try to follow it also. When I am explaining it, I am giving good time for you. So if you have any problem in exam, basically problem sum, we don't mention which method you have to follow. But when question is given and instructions also there to follow long division method, you have to follow long division method. And problem sum, we don't mention which method you are going to follow. You may follow prime factorization method, you may follow long division method, you may follow Vedic method also. Okay, this is up to you. Next, now I have to explain some of the question from our textbook. You see, in chapter of the textbook, square and square root. Okay. what are the areas you have to remember. So uh, so please, whatever I'm putting tick mark on this part, you have to remember. So square of 20 it is given, but I have shown you 30. You have to remember the table of square from 1 to 30. Clear? Now, can you say whether the following numbers are perfect square? How do we know? That is the rule. Properties from this I have given from the chart. Ki number ending with 2378 will never be a perfect square number. And other than 2378 may be a square number. Not sure, maybe. So here number ending with 7, so it will not be a perfect square number. Number ending with 3, not be a perfect square number. Number ending with not a perfect square number. Number ending with 2, not a perfect square number. This number ending with 9, it may be a perfect square number. Number ending with 1, it may be a perfect square. No need to perform this activity. Only you have to say may be a perfect square number or may not be a perfect square number. Are you clear? So now this is the square up to 50. If you can remember, very good. Okay, this table, please try to learn it. Okay, it will help you. Someday before I have seen a clip, class 2 standard student, she has learned till 100, square of 100, 1 to 100. So you are in class 8, you can also do it. Please be careful. So it will help you a lot when you are appearing for competitive exam. This table will help you a lot. And one interesting pattern that which I have shown you, number ending with this. So 2378 will never be a perfect square number. This is given. Okay. Now it is the triangular number. In my previous class I have shown you the sum of the two triangular number is the square of the next number. This concept you have to apply. Clear? Pattern also. You also know the pattern. Square, one square. Sum of the two consecutive square odd number is that two consecutive number, odd number means 2 square. 3 consecutive number means 3 square. 4 consecutive number means 4 square. 1 plus 3 plus 5 plus 7. How many odd numbers are there? Starting from 1. 4, that means 4 square. 1, 2, 3, 4, 5. 5 consecutive odd numbers are there. That means what will be the sum? Directly 5 square. 25. It will be. There is no any exception from this method. Okay. If 7 odd numbers is there, 7 square. 10 odd numbers are there, 10 square. Clear? Easily you can find out this. So this is another part I have explained before also. Now exercise this. What will be the unit digit of the square of the following number? So you have to say, no need to perform the square root. You have to say number ending with 1. What will be the unit digit? Unit digit 1, it definitely will be 1. 2, when it is a 2, what is the link with 2? Either 4 or what? Unit digit of the perfect square. 2, 4 or another is 6. How can I get back this? That table you have to learn here. The following numbers obviously not a perfect square. Give reason. Same 2378. Wherever 2378 is there, there will be that number will not be a perfect square number. This is some of the patterns you have. It is given. Okay, I have explained in my previous class also. Nothing is there. Now next exercise is Pythagoras triplet. I have already explained some of the members when it is given from the textbook or not. So m, 2m and m square plus 1. This is the expression 2m m square minus 1 m square plus 1. So it is given in your textbook, but I have shown you in Vedic method also. Okay, to find out the Pythagoras triplet. Find the square of the following number. How? How can I do? Square of the following number. How can I find out the square? I have shown you what? One is algebraic method, one is box method, another one is Vedic method. Okay. So whatever it is you are feeling easy, you can follow that particular methods. Pythagoras triplet, 2m, m square plus 1, m square minus 1. Okay. The 2m is here. You will follow it. So these two questions are important. Clear? Square root. Now you see the square root of the following number. By square root we are finding by prime factorization method, and then another one is the long division method, and last one is the Vedic method. Okay, Vedic method only applicable for whole number. Okay, so whether it will be a one digit, possible one digit, you have to say that from that chart. Without doing calculation, find the number where surely not or not perfect square. Number is 2378, 3 hai, so it is not a perfect square number. 7, not a perfect square number. 8, not a perfect square number. 1, it may be a perfect square number. Okay, so now here they are saying find the square root of the following number by prime factorization method. That means we have to break down this number into prime factor. After that, you have to underline the pair of numbers. Okay, so all perfect number can be represented as a pair of equal prime factors. So when instruction is given, they are perfect square number. So you always will get a pair of perfect prime numbers. Okay, so no problem. Now here these two questions are different. These numbers are not a perfect square number they have given, but you need to multiply by smallest number so that it becomes a perfect square. Now we will perform the prime factorization method. You will notice one or two factors having no pair, so that you have to supply, you have to give them, make it a pair. That will be the answer, and after multiplying, what will be the square root, you have to find out. Same here, if you perform the factorization method, so we will see some numbers are missing, pair is not there. You have to remove all this unpaired number from it. That is the answer, and after removing whatever I am getting, that is the another part of answer. Clear? Now next one is what, some problems, some must be there. Here square root. Now find the square root of the following by long division method. I have already explained. Okay, this is very important question. Find the number of digits. It is interesting. It may be given in your class state also. How many pairs are there? One pair, so one digit answer. How many pairs will be there? The number of pairs, number of digit after squaring will get. How many pair is there? Two pair means two digit answer. How many pair is that? 1, 2, 3. So 3 digit answer. How many pair? 1, 2, 3. So 3 digit answer will be the. You need how many digit of the square root without calculation. So just put a bar. The number of pair means number of digit. Clear? Find the square root decimal number. I have given an example of a long number. So you have to put a bar from this side and you have to put a bar from this side. After that you have to perform the long division method. Okay. So same here. This you have to practice at home. Okay. Now find the least number must be added or must be subtracted. That means you have to follow long division method. You have to follow long. Perform the long division method. You will notice something is coming as remainder. Now when it is there, how much you have to subtract. Okay, whatever the remainder is coming, remainder is the answer. But in this case, what is the least number to be added? You perform long division method, some remainder is coming. Say मान लो कि whatever question part is 30 and remainder is coming 15. So this number is greater than 30 square but less than 31. I have to make it 31 square. So that time we have to add something with the remainder so that it becomes a perfect square number. So in case of subtraction rule, whatever the remainder is coming, that answer, and in case of addition rule, whatever the quotient is coming, that one more you write down. Okay, and that square minus given number is equal to your answer. I have explained this part in our previous modules also. I think you have downloaded that video clip, or if you've not, it is given in the WhatsApp group. You again see this previous class, you will make out. Okay, a gardener has 1,000 plants. He wants to put them in a such a way, number of rows equals to number of. Find the minimum number of plants needs to add. That means 1,000 is not a perfect square number. I have to arrange it. Some remainder is coming. Whatever remainder is coming, I have to add something. That means you have to follow addition rule. So whatever the quotient is coming, we have to make it one more square. And thereafter subtract this 1,000. That many plants we have to add. So 500 children in a school. 500 is not a perfect square number. You have to perform what? Number of PTD in such a way, number of rows equal to number of columns. So let the number of rows be x, the number of column also x. The x into x equals to this. But if we perform this square root by long division method, some remainder is coming. So they are saying how many child will be left out. That means remainder is the answer. We don't have more than 500 children. You cannot add some more children also. That's why whatever remainder is coming after performing long division method, that is the answer of this question. Clear? So this is all about your square and square root. Some important area I have just put tick mark. Okay, area of the square. Okay, whose area is 441. Let the side be x, another, therefore area side square, that is x square is equal to this 441, or x is equal to root over 441. So perform long division method or prime factorization method, you will get the answer. Okay, or Vedic method also you can apply here. Okay. Clear this one? So this is all about today's class. We have class on Monday. That day I will revise what? No, next class will be what? On Thursday, I think. Okay, Thursday. That day I will revise the last chapter, that is understanding quadrilaterals. Thereafter, on 30th, that is Saturday, we will have a what? Online class test. What way I will conduct, I will give you details through WhatsApp only. Okay. Till then, bye bye students.